Lesson 6.5 talks about trapezoids and kites. So let's go over what a trapezoid is. A trapezoid is any four-sided shape that has exactly one pair of parallel sides. Okay, those are called the bases. All right, now if your trapezoid has two parallel sides and the other two sides are congruent, that is called an isosceles trapezoid. A kite is a quadrilateral with two pairs of adjacent sides congruent. Nothing about a kite is parallel. So the first concept we're going to talk about deals with an isosceles trapezoid, okay? Which is when those two sides that are not parallel are congruent. It says the base angles of an isosceles trapezoid are congruent. All right, so let's look at an isosceles trapezoid one more time. We have the two parallel sides, which are called the bases. I'm going to call this base 1. I'm going to call the bottom base 2. Okay? So the base angles. So this is a base angle. It is congruent to this base angle, which means the two top base angles would be congruent to each other as well. Now also remember that these form the letter C, which make same side interior angles. Same side interior angles are supplementary, since we have parallel lines and a transversal. So here we have an example. We have an isosceles trapezoid, ABCD. It gives us the measure of angle B, and we're going to figure out all the rest of the angles. Now, judging from the last concept, I know that angle B would be congruent to angle C, because they're base angles. They're attached to the same base. So I know angle C is 102. Now let's talk about those same side interior angles. This angle, angle B, and angle A are going to add up to 180 degrees. So to get angle A, I'm going to subtract 102 from 180. That's going to give me 78 degrees. That's the measure of angle A. Now angle A is the same as angle D. Those are base angles attached to the bottom base. So I know angle D is also 78. The next concept we're going to talk about inside of an isosceles trapezoid, the diagonals are congruent. So in this diagram we have an isosceles trapezoid because the two non-parallel sides are congruent. So that tells me that the two diagonals are congruent to each other. So diagonal AC is congruent to diagonal BD. Those are the same length. All right, let's move to a kite. In a kite, the diagonals of a kite are perpendicular. Remember, perpendicular means they intersect at a right angle. So that means this long diagonal and this short diagonal are going to intersect to form 90-degree angles in the middle. All right, our next example is in a kite. Okay, so we're going to find the angle measures inside of a kite. All right. Now, again, we know that in a kite, the diagonals intersect to form right angles. So I know angle 1 is 90. Let me make a little right angle mark there. Okay. All right, now angle 2. Angle 2 is inside of a triangle. So I'm going to take that triangle out and redraw it. We have a 90-degree angle, which was angle 1. Tells me 32 degrees is right here, okay? And then we have this angle 2, which is our question. So I know angles in a triangle add up to 180. So I'm going to add 32 and 90. Sorry. 32 and 90. That's going to give me 122. So subtract that from 180. Let me borrow here. 8, 58 degrees. Angle 2 is 58 degrees. Last, we have angle 3. Now, what I'm going to do, I'm going to take out this triangle right here. Triangle ABC. Now, this triangle has two congruent sides. If you notice in this kite, those are the two adjacent sides. So this is an isosceles trapezoid. Okay? Or, I'm sorry, an isosceles triangle. Now, if you take and draw a line, which is present right here, through the vertex angle of that triangle, if it's perpendicular to the base, then that means that the vertex angle is bisected. Now I know this angle right here was given to me as 32, which means the other angle is also 32. So angle 3 is 32 degrees.